Hi everyone. In this video, we are discussing problem number 1347, minimum number of steps to make two strings anagram. It's a medium level late code question. Let's read the problem statement. You're given two strings of same length. Those two strings are referred to as S and T, right? These are not the lengths of the strings. These are the strings themselves. Okay, these two strings are referred to as S and T, right? So we are given two strings of exactly the same length. It has to be of the same length. Otherwise, if these two strings are of different lengths, there is absolutely no possibility of these two strings being anagrams of each other. So what is an anagram? I'll explain that in a while. So some of you may not know, so I'll explain that later with some examples, right? So what are we supposed to do here? In any given step, we can choose any character of the string T and replace it with another character, like suitable character. What that character is, we can determine that, right? So in any given step, we can choose any character of the string T and replace it with any suitable character. They didn't say suitable, but I'll explain why it is so. Now, after we do that, we need to return the minimum number of steps to make T, the string T, an anagram of the string S. Okay, so we are given two strings S and T, and they both have same length. Otherwise, there is no chance of them being anagrams of each other, no matter what kind of replacements you do, right? So they're of same length. And in any given step, we can replace any character of your choice. You can choose any character and you can replace it with any other character of your choice. So that is what we are allowed to do in a single step. So we need to find how many such steps it takes in order to make T an anagram of S. Now here they are explaining what is an anagram. An anagram of a string is a string that contains the same characters but in different order, right? Sometimes it can be of the same order, in the sense a string and the string itself is an anagram of itself, right? If you have a string cat, is an anagram of cat itself, right? Did you get this? An anagram of a string is a string that contains the same characters but in different ordering, or sometimes possibly same ordering, right? Okay, so they have given some examples. Okay, so before we check these examples, let me just quickly show you what are anagrams, right? I'm sure that most of you know what is an anagram, but some of you may not know, so let me give you this clarification, right? And those who know anagrams, you must have seen even some clever anagrams. I'll show you some clever anagrams. Let's start with a simple example. Look at this word silent and the word listen. These two words are anagrams of each other, right? In the sense, you can take the letters of the word silent and rearrange them without including any extra letter or without removing any letter from the existing list of letters. So without doing this kind of modification, by simple reordering alone, we'll be able to get the word listen, right? You take the letters of the word silent, rearrange them in a specific way, and you'll be getting the word listen. Okay, so that makes listen an anagram of silent, or you can also say the other way around. Silent is an anagram of listen. They both are anagrams of each other. That's a better way of putting it. They both are anagrams of each other. So now it makes sense, right? Why anagrams are supposed to be of same length? Because they have the same characters. And they also have same number of each character, right? Check this example. The word, not a word, the phrase, the eyes. And look at this phrase, they see. Okay? So it's not a word. This is a phrase because we have some white space in between, right? We won't be calling them words and phrases and stuff. Okay. In more technical terms, we will simply refer to them as strings, right? Okay. I'll take you back to lead code in a while. Okay. So the eyes, they see. These two phrases are anagrams of each other. You can rearrange the letters of the phrase the eyes and you will get the phrase they see, right? And another example, Clint Eastwood, Old West Action. These two are also anagrams of each other. By simple reordering of the letters, we'll be able to convert one to the other. So I hope you understood when we can say two strings are anagrams of each other. So let's get back to the actual problem given and let's go over some examples. Okay, check this example number 1. The string S is BAB and the string T is ABA. As it is, they are definitely not anagrams of each other. you cannot rearrange the letters of the string BAB and get ABA. Okay, even though they are made up of the same letters, S is consisting only A and B, and T is also consisting only A and B, but you have different number of A's and B's in these two strings. Okay, the string S is having one A and two B's, and when it comes to string T, you have two A's and one B, right? Okay, so the output for this particular pair of strings is 1, and the reasoning behind this is simple. You take the first A in the string T, replace it with the letter B, then T becomes BBA, which is clearly an anagram of BAB. You get this? And it's not really necessary that only the first A you have to replace with B. You can even take the last A in the string T, you can replace it with B, it becomes ABB, which is an anagram of BAB, right? So it doesn't matter whether it's the first A or the last A, it doesn't matter, right? So how many letters are getting replaced? In one step, we are allowed to replace only one character of the string T with another suitable character. So how many such characters are to be replaced is the question. Okay, so that will be our output. Okay, so look at this example number 2. Two strings are given. The string S, which is lead code, string T, which says practice. Okay, and the output here is 5. This particular example, I'll take you to whiteboard and we'll discuss this in detail, right? Okay. And the reasoning is we will have to replace the letters P, R, A, I, C from the string T. You will have to replace these letters with appropriate characters in order to convert T to S, like an anagram of S, not exactly S itself, right? Okay, so likewise, we have another example. Example 3, S is this particular string which reads anagram, and T is this particular string. I don't think it is any English word. It need not be any dictionary word, right? Dictionary English word. Okay, so we are just dealing with bunch of characters. It's a string. That's it. Whether it actually means anything or not, it doesn't matter, right? The clever examples of anagrams that I have shown you, they actually mean something and it is fun, but that is not what we are dealing with, right? We are just dealing with array of characters. Look at it that way. Okay, so S is this string and T is this string, and the output is 0. And why the output is 0? Anagram and this string are already anagrams of each other, right? We don't have to replace any letter in the string T in order to make that thing an anagram of the string S. They both are already anagrams. So how many changes we need to make? 0 changes we need to make. You get this? That's it. So that is why the output is 0. And some constraints are given. The length of the string S can range from 1 to 50,000, right? And the same applies for T because length of S and length of T are same. And S and T consist only of lowercase English letters. So we don't have to worry about uppercase. We don't have to worry about any other symbols or white spaces. So it is just lowercase letters that we're dealing with, right? Let's now head over to whiteboard where we will discuss one of the examples given in the lead code. We will discuss that particular example in detail. And based on that, we'll come up with an algorithm to solve this problem, right? So consider these two strings. The first one is the string S. The second one is the string T. They both clearly have same number of letters. So both S and T, they have 8 characters. Okay. So now choose any one of these two strings. For example, I choose the string T, right? Because T is where we are going to make some changes, right? Let's choose the string T. For every single character in the string T, let us find the matching character in the string S, right? Okay, so we have P here. Do we have any P here? No, we don't, right? So P is something extra in T. And we know for sure that the P has to go. Makes sense that P has to go. Because our aim is to make some changes to the characters of the string T in order to convert T into an anagram of S. Right? As long as there is a P, T is never going to be an anagram of S, right? So that is something that has to go. But now we are focusing on what? The common letters, the common characters. Okay, we have R here, and there is no R here. In the string S, there is no R. Okay, so R is something that has to go. Okay, look at this thing, A, the next character is A. Even that is present only in T. There is no A in the string S. Okay, even that has to go. Now check this character C, and we do have a corresponding C here in the string S. Okay, so we are marking it. Like I told you, whatever is common, that we are marking, right? Okay, the next character is T. And we do have a corresponding T here, right? In the string S, we do have a T, right? And the next character is I. Again, I is something that belongs only to T. There is no I to be seen in the string S. And then we again have a C here. Do we have any C here? Yeah, we already saw one C, but that C is paired with this particular C. But for the other C that is present in T, do we have a corresponding C in the string S? We don't, right? Okay. And we have E here. And here we have E in X's. We have 3 E's. So you mark any one particular E. So I mark this for convenience. So whatever is marked here, they are the common characters. And we don't want to disturb them. We don't want to modify them. Right? We want to preserve them as it is. Because our aim is to make S and T anagrams of each other. Okay. So what is preventing S and T being an anagram of each other? The uncommon letters, the uncommon characters, those are the ones which we have to change in order to make them anagrams of each other. Okay. And in which one of these two strings we're going to apply the change? Obviously T, because that is given in the problem statement. Okay. So in this particular string T, we are going to apply changes. Okay. So what kind of changes? We will have to remove P and replace it with some suitable character, in the sense like any character that is missing in T. Okay, and that is present in S. For example, L. Okay, so in the first step, I'm replacing P with L, right? Then even R has to go, right? I told you, right? Anything that is present only in T has to go. Okay, so R has to go because there is no R here. Okay, so what are we replacing R with? You can replace R with any of the remaining 4 letters. You choose E or O or D, anything. It doesn't matter in which order you choose, because when it comes to anagrams, order doesn't matter, right? Do we have the same characters and do we have the same number of each character? Only that matters. Okay, so we replace R with E. Okay, and A, again, that belongs to only T. It is nowhere to be seen in S. So I'm replacing A with, say, this E. Okay, C is already common, T is already common, so we don't want to touch them. I is present only in T. Let me replace it with, say, O. And C, I cannot exactly say C is present only in T. That is wrong, because we know that there is a C in the string S, right? But that C is already matching with this C, which we don't want to disturb. For this particular C, you have an excess C here. For this particular C, do we have any matching C? No, we don't. Okay, so we will have to replace it with, the only remaining option is D. D. So what do we get? We get LEECTODE, right? Which is definitely an anagram of the string S, which is lead code. Did you get this? We just have to count the differences, right? So this is the idea. Okay, so this is our algorithm, right? So this is exactly what we're going to do. But before that, let me just show you the exact same thing in a bit more formal way, right? So I don't look at it like lead code. I don't want to look at it like a word. I just want to look at it like bunch of letters or characters, right? So we are going to focus on what are the characters that are present in the string S and how many times each character is repeating. Even that is a very, very important thing, right? Okay, so let me color code. L appears how many times? Once. E appears how many times? Thrice. T appears how many times? Once. C appears how many times? Once. O appears how many times? Once. D appears how many times? Once. Okay, so that is string S. Okay, likewise, let's break down the string T. Okay, let's break them down in terms of the characters. Okay, how many times P appears? I'm talking about the original T before we applied all these changes. I'm talking about the original, the given T. Okay, so how many times P appears? Once. How many times R appears? Once. How many times A appears? Once. How many times C appears? Twice. How many times T appears? Once. How many times I appears? Once. C already counted. I told you it appears twice. And how many times E appears? Once. So what do we do here? What do we call this? In more formal terms, what do we call this? this is a dictionary, right? This is a dictionary, or we call it hash table, right? This is a hash table. Okay, so we will have to start from there. Okay, let's break them down into their components, right? For both string s and string t, let's break them down into their components, right? Okay, so the code will go like this. We are starting with implementing the hash table, the dictionary, right? As we call it in Python. Okay, and we're going to use default dictionary. I hope you all know what is default dictionary. It is same like dictionary, but we automatically give some default values for all the keys. Okay, using lambda function will be convenient here, right? Okay, so it goes like this. Count underscore s is the dictionary that I'm using in order to count the letters, the characters in the string s. Okay, so count s is collection dot default dict of lambda map to 0. Of course, we will have to actually type it as lambda. Okay, and count of t is, I can just copy paste the same, collection of default dict where lambda is mapped to 0. Okay, so for all the keys, we are giving a default value of 0, right? Okay, and let's also create a variable called steps to count the number of steps. In the sense, number of steps it takes to convert t into an anagram of s. Okay, and initially we'll give it the value of 0, right? So now the first thing that we're going to do is for I in range of length of s, for I in range of length of s, you could have chosen length of t, it makes no difference because they both are equal. Okay, so for I in range of length of s, we are going to count the characters. Count underscore s of si plus equals 1. Every time we encounter a letter, we will keep updating its value, the count of that letter, by doing +1. Okay, the same goes for the letters in the string t. Count underscore t of I plus equals 1. Every time we encounter a letter in the string t, we are updating its count by adding +1. Okay, so once we're done with this for loop, then we will have exact picture. We will have these two boxes, right? What are the letters that are present in the string s and what are the letters that are present in the string t, and how many times each of those letters are appearing, that we will know once we run this for loop, right? And after that, what are we supposed to do? This is where it gets tricky. This is the crux of the algorithm, right? Let me show you this box again. Okay, we are subjecting only t to some changes. Okay, so let's focus on this box. Okay, the dictionary for the string t. Okay, we will go over all the letters present in the string t. The most important thing is we will have to call all these letters in the string t exactly once. So when we are calling these letters, we cannot iterate through the string t itself. Instead, we will have to iterate through the letters that are appearing in string t. Okay, every letter we are calling exactly once. So let me not deal with string t. Instead, let's deal with count underscore t, its key values. So we will iterate over count underscore of t, which is a dictionary. And we know that dictionary, the key values of the dictionary will act like a set. In a set, we know that objects cannot repeat, right? Key values cannot repeat in a set, right? So there is no chance of us calling the same letter twice. Okay, so we are going to iterate over this, not the string t itself, right? Okay, so what is it? For letter in count underscore t dot keys, we introduce a variable called as difference, which is literally the difference between how many times that particular letter is appearing in the string t and how many times it is appearing in the string s, right? So what it will be like, now we're going to see p is occurring exactly once in string t and p is not at all occurring in the string s. That is where this default dictionary is very useful, because we have already given a default value of 0, right? So p's corresponding value in the dictionary corresponding to s is going to be 0. So 1 minus 0 is 1. So the difference is going to be 1 for the letter p. Okay, check the next letter, r. It appears in the string t. Therefore, the dictionary value here is 1. and R is not appearing in the string S, again, we have given a default value of 0. So 1 minus 0 is 1. Again, the difference is 1. Okay. For this character A or the letter A, the difference is again 1. Okay. For C, yeah, C is occurring here. C is also occurring here. 2 minus 1, the difference is 1. Okay. So far, it's like 1, 1, 1, 1. What about this? T is occurring here exactly once. Here also it's occurring exactly once. So 1 minus 1 is 0. The difference is 0. Okay. Okay. That is 0. I is occurring here exactly once and I is not occurring. So its corresponding dictionary value is 0. 1 minus 0 is 1. E is occurring here with dictionary value 1 and here it's occurring with dictionary value of 3. So the difference is going to be 1 minus 3 is negative 2 and the difference is going to be negative 2 here, and we're not going to count it. We're not worried about zero difference. We're not worried about negative difference. We are worried only about the positive difference. Because when we have one extra letter P here in T, then that extra letter is appearing here in T at the expense of some other letter that is supposed to be there. Are you getting it? So we don't have to really worry about, okay, here we have one E, here we have 3 E's, so it is having 2 E's less. So is there a problem? Should we do something about that negative 2 difference? We don't have to do anything at all, right? When you have P here, that P is appearing in the place of some other appropriate letter, which is supposed to be there for it to become an anagram. Okay, if there is one extra R here, that R is occurring in the place of some other letter, which is supposed to be there, right? If there is one extra A here, that A is occurring in the place of some other letter that is supposed to be there. So some of these letters is what we are going to convert them into E, right? So yeah, we need to have 2 E's, but one of these letters, P or R or A or C or I, okay, one of these letters, not one actually, sorry, 2 of these letters, we are going to convert them into E. That is exactly what I have shown you here. We are replacing R with E, we are replacing A with E. We could have done that with any of the 5 letters, not necessarily R and A. Are you getting it? Okay, so we don't really worry about the negative difference. We don't worry about zero difference at all because it means it's a perfect match. Wherever there is a positive difference, that is what we are going to subject to change. Okay, we are going to modify only those letters, right? So that's the idea. And how do we express that? Check this. If the difference is positive, we are going to increase the steps by exactly that difference. And finally, we are going to return steps. So it takes this many steps to convert T into an anagram of S, right? So this is the idea. Let's now head over to lead code and code it out and see how it works, right? So like I told you, first we are going to initialize 2 dictionaries, default dictionaries, collections.default dict of. Using the lambda function, we are going to give a default value of 0 for any key, and we are copy pasting the same for the dictionary corresponding to T, which we denote by count underscore T. Okay, count underscore S will give us the letters and how many times they are occurring in the string S, and count underscore T will give us the letters and how many times they are occurring in the string T. Okay, and also we'll initialize another variable called steps, and the value that we give is 0. Okay, and here using this for loop, we are going to actually count the letters in both the strings. Okay, so count underscore S of I, we updated by adding 1. Similarly, count underscore T of I, we updated by adding 1. So once we run this for loop, like I told you before, we have a complete picture of what S is made up of and what T is made up of, what are the characters present and how many times each character is occurring. So we will have complete picture of both. Okay, so now we are going to iterate over the letters of the string T, but we're not going to directly use the string T itself. Instead, we are going to use the key values of the dictionary count underscore T. Okay, because the dictionary, the key values of the dictionary will act like a set where the repetition of letters are not allowed, right? Okay, check this. So for letters or letter, let me call it, in count underscore T dot keys, this count underscore T dot key method will give us all the letters present in the string T, but all the letters are counted exactly once, and its corresponding dictionary value will tell us how many times those letters are occurring in T, right? Okay, So we are going to introduce another variable called difference, where we are going to find the difference between the number of times that chosen letter is occurring in the string T and the number of times it is occurring in the string S. And like I told you, we are going to act on it only when the difference is positive. If the difference is 0 or negative, we are not going to do anything about it. Okay, so only if the difference is positive, we are going to increase the steps by exactly that difference value. Okay, and finally we will return the steps. Okay, so let's test run our code. Great, it worked. So let us now submit the code to see how it performs in all the test cases. Great, our solution is accepted, and even the runtime and memory usage, they are pretty decent. And I hope that you have understood the solution. Thank you for watching.